So good evening, everyone. Welcome to another Saturday. This is our sixth talk in the series where we explore the common compiler tools and how you can use it in your uh, development workplace. So this time we will talk about clang-tidy and clang-format. I think this talk should be really called clang tooling because we will not just explore clang-tidy and clang-format. We'll also look into other tools as well. So why is this talk relevant? Um, I think there's always a next KCD comic for any programming meme. So, so here there's a person who's is a very self-taught programmer, and he shows his code to his colleague, and it's not always trivial to understand others' code, right? And I've seen this in many places where I was doing interviews, especially with people who are from the algorithmic or competitive programming background, where uh, the motive is to write, solve the problem and not write, code that's maintainable. So yeah, so when you come back to, or when you go to a place or a company where you have to write maintainable code, it's hard to get to those practice. And even when you write code, there should be a way to check if this conforms to the coding standard, as well as formatting as well, and whether there are any code smells that are inherently present in the code. So that's something that we'll talk about here, and how we can automate that. And of course, there's also this survey that happened in the 1990s, where you have different phases of development, from coding, unit testing, functional test, system test, and release. And the author plotted the number of bugs, defects that were injected during the process, as well as defects found during testing, as well as the cost to repair the defect. So during coding, that's when you will actually inject a lot of defects, because that's when you're developing code, and over the process, your defects goes down. But when you start integrating with the larger system, you start to increase a bit, because you haven't tested the interface boundaries. And as well as the defects are found later in the process when you do a lot of testing on the code, and the cost to repair the defect increases in an exponential fashion um, towards a release, because when things are out, and you break something, and there's a lot of chaos, and you not only have to deal with the technical aspect of it, but also the customer standpoint, and the system that's affected. So there's a lot more at play when things go out, out of your development environment and into the hands of the customer. So we'll explore some of the tools that we can use to solve those problems. At least these are not the holy grail. These are some of the tools that we can use to avoid some of the defects that we can encounter during the development process. So as usual, we'll do a hello world. This time it's a clang-tidy or clang-format talk, so we are going to do a different version of hello world. I hope this works. So this is a buggy hello world. I hope you guys can see my screen. So this is Godbolt. If you guys don't know about it, so we did a talk a couple of weeks ago by Ashutosh, where he talked about how to use Godbolt to effectively optimize your workflow, and how to use to learn C++ and other languages easily. So what you can see is, oops, okay. So what you can see here is that I have a hello world that's written in character star, and there's a problem here that I don't have a slash null, or a null terminator at the end. So what printf does is that you're trying to print a string, so it looks to the argument, and prints it to the standard out, until you see a terminator string. And here in this case, you can see that it does not find it, and it starts to look beyond the actual buffer itself. So these are some problems that you'll run into. So in the production environment, and there are checks that you can use. So this is a clang-tidy check, and so this is part of the Godbolt Explorer. So you can do, what you can do is you can add a tool called clang-tidy here. So when you add it, it gives you this window where you can add checks. So I've enabled all of the checks, and here you can see that it's looking for modernizing training return type. So in C++ 7.11, you can add training return types that looks more like a functional style programming. And here there is a C++ code guideline check. So these checks look for some patterns in the code, and point out if they are invalid. So here the check says do not declare C style arrays, use std array instead. So C style arrays are pretty old, and they are part of the C language specification, which C++ inherited, and C++ now has a more type safe std array that you can use. Again, there's another warning says do not call C style vararg. So printf is a variadic function, or a variadic C function. So you can pass arbitrary number of arguments to it, and it retrieves to them, and does all the printing work. But it's not recommended because it's not very type safe to do it. And again, do not implicitly decay an array to a pointer. So here we have point an array that's statically declared in the main function, or it's local in the, and you're trying to decay that to a const char star in the function here. So it's warning that you don't have to do a decay. So these are checks that you can implicitly do with clang-tidy. Of course, we'll look into more of it, but yeah, these are the checks that you'll implicitly see when you run it. And this is just to give a feel of how the tool works. And going back to the talk. So before going into the tool itself, let's see how the Clang compiler works, and see how these tools utilize the Clang front end to do all these sort of analysis. So this is the Clang compiler flow. So you have a C or C++ or an OpenCL Objective C file, and you pass in a set of flags, and what the Clang compiler. So the whole thing is part of the Clang driver. So which drives the compilation process. So it invokes the front end, the middle end, the back end, the assembler, and the linker, and the pre-process, and it hands over all these intermediate files to each of the tools that's coming after, so that the whole compilation process is complete. So we'll look into. I'll show you how you can view this thing. So if you pass -cc print faces, so it'll tell you the face of each compilation. So the input is a source C++ file, and then next it executes the preprocessor, then the compiler, and the backend, and then the assembler, right? Um, so so this is part of the Clang driver, and it's more of a basics. It's also like a tool that invokes the Clang front end, so which is a different thing from the Clang driver. Um, and we'll see. So this is the main part of the Clang front end. So it includes a custom preprocessor and a parser, as well as the semantic analysis phase, as well as the code gen to LLVMIR. And so you can also do some sort of print token. So in the front end, the first phase is to tokenize character stream or the program. So here you can see there's a main program, there's a hello world, and there's a printf function. And here it doesn't have to compile because the printf doesn't exist. So all you have to do is just dump the token stream, and you can see that each token has its own identifier, and It's just to say that you can view each part of the compilation process through the command line, and it's very easy to access. And we'll also explore the other phases as well. So you can also view the AST. So after the preprocessor, you get the token stream here, and after the token stream, when you do the parsing and semantic analysis, you get a functional AST, and you can view the AST here. So this is a simple class. So you can see a widget class, and it uses a it has a member named Pimple, and you can see this vast information of the AST. So AST is basically a tree that encompasses that that's built from the program, and every it's built for every translation unit. So the topmost level of an AST will be a translation unit, and here you can see that that's a translation unit decal, and there are different things that are under it. For example, there's a namespace decal, so I've declared a namespace here. So namespace is another hierarchy in the AST. So AST is basically a tree. So you can see the hierarchical representation here. So the namespace decal, and under that namespace decal you have a class template that's called unique pointer, and each class has its own the 6 default constructor, copy constructor, move constructor, copy assignment, and move assignment, all that stuff. And again, you have an end of the namespace. Yeah, I have declared another class called widget, and it has its own constructors and the member variables. So the member variables are represented using CXX record decal, and you can also see that the field is its name is Pimple, and the access specifier is public. And there's also a method called draw that's here. And let's say if I uncomment this, I declare some member functions. You can see that the record decal or the class has some more fields now. You can see that there is a constructor declaration, destructor declaration, and there's also move constructor. There's also a copy constructor which is deleted. You can see those attributes that are or the declaration that's deleted, so it's no longer usable. So this is the rich information that you can get from an AST, and this is also something that you can get programmatically through the Clang API that's exposed. And if you want to develop some tools and you want to see how to traverse its AST and how it looks, you can use the -xclang -ast dump option, and then you can view the AST here. That's the AST. And now after AST, it's basically code generation to LLVM-IR. And during this process, there are different sort of tools that Clang uses to manage, the compilation process, basically language options. So there are Clang supports different languages like C, C++, OpenCL, and each have their own sort of language options. And source manager is something that manages the source, and so all of this allows Clang, the system that allows Clang to function also as a library. So all of this information that's present here can also be accessed via external tooling. So what you can do is you can link against the libclang API or the different interfaces through the Clang front end, and you can access all these individual information. I think that's most of it. So there are different internal representations. This is something that I want to distinguish before we go into the actual set of tools, because each of these tools use some representation of this. So AST is an abstract syntax tree, is the primary abstraction upon which tooling is based. ASTs capture essential information from the source code and act as a scaffolding for semantic analysis, example type checking, and as well as code generation. So so the semantic analysis phase as well as the code generation phase use AST as the representation. So if you want to do some sort of a type checking, whether a given type is valid for the expression, or if you want to select an overload for a function, all this information is accessed through the AST. And if you want to generate code from LLVMIR, what Clang does is it sort of has an AST visitor. It walks the AST to generate the LLVMIR from that representation. And there's also a CFG, which is something like a pseudo CFG, because it's not sort of like a true CFG of the program itself. The Clang CFG, short for control flow graph, represents how the theoretical computer would execute the statement encoded in the AST. So Clang sort of builds a CFG from the AST representation and uses it to do some uh, code analysis. So it can be used to okay, that's some typo. So it can be used to do control path sensitive analysis like live variable analysis, lifetime analysis, etc. So there are links to how these are being done. You can go and check it out. So lifetime analysis is something that that's being worked on to allow lifetime analysis on C++, which is similar to what Rust does in a system. You can also view the CFG if you want. So I can show you how it works. Sorry, how it looks. So here is a simple code where there is a switch case statement. So you can see how the CFG is represented. So here there's a concept of basic blocks, and each basic block is terminated by some sort of a branch instruction. And here that's function B, and there's an entry block. And each of these statements here represent some nodes in the AST. So you can see an implicit cast expression to an int, and I can the yeah. So that's a written statement here that's A, and it there's a cast to that. There's implicit cast to that, and there is another statement where there's int AC and or then another basic block where there is int A and int C, and it branches to a switch statement, and each of these has a predecessor and successor. So it's basically what a control flow graph looks like in if you look at the LLVMIR, but it's more based on the AST versus the LLVMIR style CFG. Uh, so this is not particularly important when you are using the libclang API unless you're doing some sort of a data flow analysis of some sort there, or some sort of a path sensitive analysis. So the link is there, so you can go and explore how the CFG looks like. Yeah, let's get back to it. So some terminologies. So we'll see what's a lint is, or a linter tool. So lint is the computer science term for static code analysis tool used to flag errors, programming errors, bugs, stylistic errors, suspicious constructs. The term originates from Unix utility that examines C source code. So clang-tidy is a linter that looks for some stylistic stuff in the program and reports it. So static code analysis is analysis of computer programs performed without executing them. So you sort of do you try to deduce some sort of property from the code without running it, and you try to see sometimes you try to predict some part of the execution flow from just statically looking at it. And dynamic code analysis, on the other hand, is performed during execution of a program. So you do analysis while the program is executing. So for example, there are tools like sanitizers, code coverage, Valgrind. So Valgrind is a tool that allows you to detect memory leaks and a lot more other stuff. So we'll explore the sanitizers and code coverage in the future talks. I think code coverage is the next presentation, if I remember correctly. So Clang tooling. So Clang tooling provides infrastructure to write tools that need syntactic and semantic information about the program. So Clang tooling allows you to build tools that uses the syntactic and semantic information, that which is basically the AST. So it'll give you an AST functioning AST if it can build, and then you can play around with it, as you saw in the previous link in the God ball. So Clang tooling needs something called a compilation database to figure out the specific build options for each file. So when you try to run Clang or any sort of a Clang front end on the program, it needs to know how to compile it. For that, it needs to know what the options are. For example, if you define some sort of let's say you're using C++17, Clang needs to know if the program is compiled for C++17, because there are some features that are not allowed in earlier versions of C++. So it needs to know how to compile it. So Clang compilation database is something that you can use to compile programs. So, sorry, use to provide this information to Clang, and it's basically a JSON file which consists of an array of command objects, where each command object specifies a one-way translation unit is compiled in the project. So there are a couple of ways you can generate the compilation commands.json, which is through cmake-d cmake export compile commands equal to on. So when you run it through cmake, it'll just dump in the build folder, and you can use that and pass to the Clang tool which that you're using, and it'll be able to successfully load and parse your program. Or you can also use some tool like bear. So bear just looks through your build command. So let's say you have a make file system, you won't be able to generate this JSON file. What bear allows you to do is it inspects the make command and builds this compilation database based on that. So yeah, if you're using other build systems like make or basil, you can use this tool. So the tooling itself is exposed to different interfaces like libclang. Libclang is a C interface, and there's also libtooling, which is a more advanced C++ interface that gives you total control of the AST, or the Clang front end. And Clang plugin is another is a library methodology where you can load libraries that you've built, and you can use it to change the actual compilation process. So for example, let's say you want to there's a tool called clad, which does automatic differentiation on C++ code. So it's written as a plugin, so you can load that library during any C++ compilation, and it automatically differentiates the code and generates source file where you have these functions differentiated. So it's more of a library interface, versus the libtooling allows you to create an executable like tool where you can run on other programs. So that's the different ways you can do tooling. So there are different tools that are already present in the LLVM project. So for example, we'll explore what clang-tidy, clang-format is. clang-d is another tool that allows you to do Clang, that provides the language server support. For example, I have a VS Code here. So here you can see I have a C++ code, and what a language server would do is it analyzes the program, and at each point it provides some information that you can use to autocomplete code. For example, if I do v.1, it understands that v is a vector, and it says that there are these functions that are available for a vector, and I can do auto completion of that sort. So clang-d is very powerful. It's also more scalable. So there are different extensions. For example, Microsoft has this IntelliSense. I believe clang-d is much more scalable than IntelliSense as far as I've used, and it's available on our platform. So you can hook it with Vim, C-Line, VS Code, and a lot more IDEs. So Clang query is a tool that allow you to develop matches. So matches are something that you'll need when you are matching with different parts of the AST. So you have like a DSL that will allow you to let's say I want to match only the struct in AST. I can write a matcher that that walks the AST in some fashion and then looks for these nodes and does some certain actions that you define on them. Clang check is the tool that runs this Clang static analyzer, and Clang doc is the tool that allows you to generate documentation based on your based on the commands that you've given in the code. Clang ripple is a new tool that's being developed that allows you to do that allows you to have a ripple like interface or interpreter-like interface to C++. It's being developed as part of the or the initiative is being taken by CERN to support the Cling interpreter project. So if you guys are interested, you can check that out. So because they are actively developing right now, and there are a lot more tools that are under the Clang umbrella project. So it's actually available under clang/tools. You can look at the list of tools that are available there. Now we'll look at the very basic tool, so which is clang-format, how you can invoke clang-format on your actual source code. So clang-format is a widely used C++ formatter that allows you to format code based on YAML configuration file. You can also invoke the clang tool to command line interface and compile it without this configuration file. But yeah, most projects use that file to automatically format their or have a uh, universal formatting in configuration file. The configuration file can be automatically generated using clang-format, which comes with predefined set of styles. So the default formatting style is LLVM, and you can also, styles include GNU, Google, Chrome, Chromium, Microsoft, Mozilla, WebKit. So each have their own different styles. I'll show you an example of how that looks. So clang-format. So this is how you run the clang-format. This is the basic version. So let's say um, this is the source code that we want to format, and let's say clang-format. I have a clang-format installed, and what if I do clang-perf vector invalid argument, unknown reading error. Okay, that's the problem with live demos. Hmm. Cool. Okay, I think there's some problem with the configuration file that I generated, so that's why I've been getting some errors. Uh, so this is the code that that's formatted. So what it will not actually modify the source itself. You have to pass another option to actually in place modify it. I'll show you how what that is, and this is the basic invocation of the clang-format command. It outputs a formatted file. I think it's all already formatted. So if it just do some sort of modification like this, so this is still a valid C++ program, but it just to format. So you can see that I've modified it here, but it's formatted output is here. I'll tell you how to in place modify that. So you can also choose styles. So from the predefined determined set of styles, so you can have style equal to Google. So Google has the style. There's also GNU. So GNU has the return type in a new line and the function in another line. So you can see you can have formatting settings like this. Let's say Mozilla. Hope that works. Yeah, I think Mozilla has a similar interface. So, and LLVM is the default one. So you can see that the formatting itself changes for different styles. And you can have that you can have a generate a configuration file that exports that style. So if you want to in place modify that based on the or if you want to modify the file based on the style, so you can pass -i flag and I now this code is modified. mm, hmm. Oh shoot, say different file. I think this is the file. So it's GNU. Let's say I've modified to LLVM. Now it should be this. So it changes with different formatting style. Let's say we made it to Mozilla. So it in place modifies the file. So you can, if you have any file that requires formatting, you can just directly do -i and then just, you can use the default style and modify that. And the other thing that you can do is you can dump this format style. So -style equal LLVM and then -dump config. It actually dumps this configuration file that clang-format uses. So let's view this one. Format. So you can see this configuration file that contains the language. It's for C++ and style based on LLVM, and you can see all these different set of options. So after class label false, so each denotes each syntactic part of the code itself. And you can there are cases where if you want to limit the column length to 80, so you can have 80 characters in a column, or, I mean in a row. Let's say you have a wider monitor and you want to utilize that real estate, you can actually increase the column limit to some larger number. Let's say your company has a lot of big monitors and you want to utilize that space, you can just increase this limit. So it you can configure the clang format based on your project requirements, and what you can do is you can just export this clang format into the top level directory in your program, and you can invoke clang format. So with Visual Studio, you can actually basically what you can do is you can just do format, and it automatically formats the code. So it picks the .clang format file from the directory. So it looks each of the parent directories and finds if there is a .clang format, and uses that to format the code that I have here. So most projects have the .clang format checked out in their top level directory. So it's advisable to have to have a uniform formatting style, so that nobody has to look through code that's really different, like I showed in the XKCD comic at the start. So it allows you to have a uniform formatting for your project. So moving on, so clang-tidy. So clang-tidy is another tool that we'll talk about today. And so clang-tidy is a clang-based C++ linter tool. Its purpose is to provide an extensible framework for diagnosing and fixing typical programming errors like style violation, interface misuse, or bugs that can be deduced via static analysis. I think that's self-explanatory. clang-tidy is modular and provides a convenient interface for writing checks. So if you have a project that requires specific checks, you can write your own clang-tidy check and look for those errors. I'll show you what the checks that are available right now. I've already shown you some sort of C++ code guidelines checks. You can write your own checks for your project that if required. clang-tidy attempts to read configuration from each source file for each source file from a .clang-tidy. So like the .clang format file, you have a .clang-tidy file where you can write all these checks, and you can automatically run these on the source code file that's located in the closest parent directory of the source file. So I think this is similar to how .clang format works. The whole list of checks are here. So let's look at the checks itself. We have a whole lot of checks in clang-tidy. There's project specific checks. So Appsale is a Google project, and they have defined this, checks for them. So if you are developing for Appsale, you can run these checks on your code to make sure it's based on their coding standards, as well as I'll show you some of the checks as well. And you can also see that you can do some sort of as a fixes. So the tool not only looks for those code patterns and the code smells, and it allows you to it provides an alternative fix that you can actually apply the fix in the code. So if this check finds an error, and it will also will provide a fix for that. So these are there is a ton of checks that are available in the clang-tidy web page that you can check it out. So it also invokes a clang analyzer, which we'll explore in the future slides. So these are the set of checks that are available. So you can also look at each of these checks and see what they do. They have a very good list of examples where you can check out what the actual checks do. And going back, so we'll talk about one list of checks that are available that I would recommend you to use. So that's called the C++ code guidelines. So it's a document that's authored by Bjarne Strustrup and Herb Sutter. So the guidelines are focused on issues related to interfaces, resource management, memory management, concurrency, affecting the architecture and library design. So this document lists out some set of rules that you need to follow to write more safer, uh, allows you to write more modern C++ code. Following the rules will lead you to uh, lead the lead to code that is statically type safe, has no resource leaks, and catches many more programming logical errors than that is common today. So you can actually run clang-tidy checks that have these code guidelines that are baked in. So you can just run the checks on your code and make sure your code is safe, and it'll run fast. You can afford to do these things right. So these checks are very quick to run. You can have a look at these code guidelines here. It's very useful to understand the modern aspect of C++, and the document is very beginner friendly. So I think this is one extract from the document. So this document is a set of guidelines for using C++ well. The aim of this document is to help people to use modern C++ effectively. By modern C++, we mean effective use of the ISO C++ standard. Currently, that's the standard is C++20, but also all of our recommendations also apply to C++17 and the early versions of C++. In other words, what we'd like your code to look like in 5 years' time, given that you start now in 10 years' time. So it provides you to write more safe and portable code that lives across generations. So you don't, that's safer and that's more modern as well. Clang-tidy demos. So C++ code guidance macro usage. So this is one check that's available. So we'll see how to use it. So clang-tidy -check. So you can actually run this check here. Checks equal to this, and oops, uh, macro usage. So the macro file itself is this. So I have defined a bunch of macros. Macros are not actually, it's part of the C standard, and C++ has a lot of alternate functionalities to allow macros. So you can do a lot of wrong things with macros. Macros are just text replacement, and people do all sorts of crazy things with it. It's easy to get things wrong. So what the checker advises is that macro C used to declare a constant. So C defines a constant here. What it what you can do is that consider using a const expr constant. So instead of C, you can define a const expr. So something like this, const expr in C equal to 0. So it defines a constant in the global scope. Uh, and there are other checks like function like macro f1 used, consider const expr template function. So what it allows you to do is it uh, allows you to replace or it advises you to replace macros with const expr functions. So const expr functions can be executed or evaluated or possibly evaluated in compile time. So that is something that you can run these checks on to see if you have any code spell like that. And again, there's a bunch of more checks. So this is another check from the code guidelines that says, so C++ guidelines, no malloc. So I have this code called no malloc. So what done here is that I've allocated an integer array on the heap, and I'm sort of accumulating that over, and I'm doing a free. So this is part of the C standard. So you use the old C functions like malloc and free to do memory management. So let's see what the code or the clang-tidy checker does. So what it says is, do not do memory management, manage memory manually. Consider a container or a smart pointer. So you can instead have something like a container. So I've allocated an array, so you can just basically have a std vector of int of a of size 10, and then do some sort of a dot begin and a dot end. So what I'm saying is that you can run these checks on your whole code base just to direct code smells like that, because it's easy to write a malloc or code that does these sort of memory allocation manually versus automatically. You can also replace this with a unique pointers to unique pointer of int, which is basically a more safer pointer, and you can just avoid free because it automatically releases this region of memory. I think you have to give an array definition like this, so it automatically releases this region of memory for without you to remember to write free. Right? It's easy to forget free, and these are part of the larger vulnerable security problems that people face in real code bases. Okay, going on. So there are not only that it gives some code changes that are more safer and more modern. It also gives you some performance advices. So for example, this is another check. So performance inefficient vector operation. So I have this code called perf vector op. So perf vector op. So I have this code that declares a vector and it iterates over the vector by pushing in some value. So what it does here is so vector is a container that grows as in it grows twice when it out of space. It amortizes this growing by allocating a double memory space, and then allocating a double of that when it you know when it goes out of memory. Um, so so what you can do is that here you're iterating over a fixed number of iterations. So you don't have to do this sort of memory runtime memory allocation over and over again. What you can do is when I run this check, it says that pushback is called inside a loop. Consider pre-allocating the container capacity before the loop. So what you can do is you can just do a v dot reserve, which allocates that many n number of slots in the heap, and you're already pre-allocated. You don't have to do a pushback on that, right? You can just do a vector of I of 2 of n because it's already allocated, and you can just index into it. You don't have to do grow this twice every time. You can just use that pre-allocated space. So uh, the interesting thing is that I've already mentioned that these checkers come with a fix, so you can use -fix that applies this. So it has a reserve here, and it automatically writes a reserve for me. So I can just call that fix, and it'll automatically fix this code smell. That's that. I think a good place to stop for questions. Okay. If you guys have any questions, yeah, please type it in chat. If not, we can move on. Okay, cool. I think there are no questions. So moving on. So Clang static analysis is another powerful tool. So Clang static analysis is a source code analysis tool that finds bugs in C, C++, and Objective-C programs. I think that's a question now. Okay, the fix only added reserve but didn't remove pushback. That's right. Yeah, I think it does not fix all of it. You can do all sort of crazy things in the pushback, so it cannot analyze it. Let's say I have a I can push back different, let's say I have call a function func, and I return much complex values, or I can do all sort of things here. It's not easy to replace that. So I think it it provides that fix, but I think you have to do some code cleanup to actually make the code work. Yeah, I think that is something that
Yeah,
that's a
after,
limitation of this tool. Yeah.
yeah, after reserve, you still need pushback because reserve just allocates the memory, but doesn't
Uh,
let you use it until you push back it.
oh yeah. I think yeah, I'm mistaken as well. I think yeah, reserve. Yeah, you have to do a pushback again. Yeah, I'm sorry. Yeah, I assumed that's resize. Yeah, thanks for that. In which case, yeah, you shouldn't replace it with v of I dot. Yeah, this is not allowed because it's still reserved, but it's you cannot do a direct index into it. You need to have a pushback. Yeah. But in this case, yeah, it'll not grow. It'll use that reserve memory to do that. Cool. Yeah, thanks for that. So coming back to Clang static analyzer. So Clang static analyzer is a source code analysis tool that finds bugs in C, C++, and the Objective-C programs. So Clang static analyzer uses both the CFG and the AST. So I think some of the basic checks can be done on the AST, but if there are checks that require some control sensitive information, that let's say I have different value, I have to check if the values available in some region of code. You cannot just look at the AST to determine that information. You need some sort of control flow information for that. So you need a CFG. So it can do static analysis across multiple translation units as well. So far we've seen just one translation unit. You can also have checks that works across translation units. You can see the list of available checkers here. So same as clang-tidy, you have a list of checks that you can do on the code. These are more complex checks, and mostly you can see a lot of security based checks. So stack address escape, null dereference. So if you have any security critical program, it's very recommended to run some sort of a static analysis tool to detect code bugs. So there's new delete, because let's say you have a use after fee, you just have to do some checks that detects those. Again, I think you can see in the C++ code guidelines, it's not used manual memory management. Dead stores and nullability checkers. So you can explore all these kinds of checkers when you get time, but yeah, I think we'll go over some of them in this presentation. Yeah, just to give you a demo. So plan static analyze demo. So the leak demo. So Clang static analyzer works differently from clang-tidy in the sense that it's baked into Clang itself. So it has a much more user-friendly interface. So for example, I have this tool called scan build that runs the build command on this. So I'll show you the program first. Memory leak IPO. So I have a complex function like this. I have two functions. So I'm allocating the pointer here, and if the pointer is it's not null, and I execute this process, and based on the condition, it does a free or not. So there are cases where the free might not be executed. So this part in the program, if the condition is false, the free is never executed, right? So that is a use of or a memory leak here. So what I can do is I can run the clang analyzer or clang static analyzer. So you do it by passing hyphen hyphen analyze memory leak.ipo, and it runs the analyzer and prints a warning says potential leak of memory pointed by the pointer PTR, and it generates a visual report. So what I can do is I can just run this scan view of this report, and it automatically opens this browser window, and you can view this report. So it gives you a visual representation of what's happening. So first, memory is allocated here. Assuming the pointer is non-null, taking this true branch, there's a potential leak of memory pointed out by PTR, right? Because the free is here and it's not executed. So because there is a potential memory leak here. So it gives you a more visual interface to the problem. I'll also give you a much complex example where we've run this on a code base. So stack escape demo. So this is same thing as the memory leak itself. So so this is the other program. So what it does here is that I have a test program that allocates memory on the stack, which is string, and you have a global pointer p. It's not advisable to have a global variable and use it across functions. What I'm doing is that I'm assigning that string that's statically allocated on the stack and to its pointer, and then calling that program and trying to print the value of p. So this is straight out bad, right? And because it's undefined behavior to access that's beyond your stack, and that's probably dead. So what the Clang static analyzer does is that, oops. So address of stack memory associated with the local variable the str is still referred by the global variable p upon returning to the caller. So this will be a dangling reference. So it also refers to the checker that it runs, and you can also see the report that's generated. So you can see the visual representation here. So address of stack memory is still referenced by the global variable p. So this is much more richer than what the clang-tidy tool does. It's more of a command line tool, and yeah, you can have much more. So there are much more advanced tools built on top of Clang static analyzer. You can use the report that's generated by the Clang static analyzer tool, and um, run that through other tools to do much more complex visualizations. We'll not go into that, but yeah, there are tools that are available that you can check it out. So thanks to Asutosh who pointed out the Stockfish repository. I was able to run this Stockfish demo. So what I did was I cloned Stockfish source file. So what Stockfish is that it's a chess engine that allows you to predict chess moves. Um, there are multiple moves apart, so it'll allow you to figure out which is the best move to take given the configuration, and a lot of other stuff that it comes with. So what I did was I built that. It's a C++ project. I built that, and I ran the Clang static analyzer to see if there are any code issues. So I ran that, and let's see. So I think there are some errors that the Clang static analyzer detected. So bug type, so there are different bugs. Array subscript is undefined, dead initialization, dead nested assignment, dereference of null pointer. So this is serious. I think it's in a different file. So I think uh, they have it in a intrinsic file that's used in the system headers. So that's something serious. Uh, and a result of an operation is garbage or undefined. So let's see what that is. So you can see it'll allow you to interactively go through the path and see where the actual problem is. So loop condition is false, execution continues on line 816, so you can go back to that. Assuming this field has unique is true, and then taking that branch. So left operand of this greater is a garbage value. So this is a garbage. It's predicted to be garbage value. So yeah, it's a static analysis tool, so it sort of tries to predict things, and it's very useful to see if if this is the case. There are some false positives that happen with static analysis, because you cannot predict the actual runtime behavior from just looking at the source code. But it's good to analyze and understand what the code does, and go through if this is the actual case in your code base. So I think that's it, and there's an uninitialized argument value here. Yeah, I would recommend you to do that. So what I did was I just did makefile, and so this was a simple makefile. So I was able to change the compiler to Clang and then add the analyzer flag, and just ran make scan. Sorry, what? Yeah, this is the command that ran. So I use Canball because Canball allows you to generate this interactive report, and run the build command itself. So and then I was able to generate this interactive script. I think that's the Clang static analyzer demo. So what's the difference? So you've seen that there are some checks that can be done in both clang-tidy and clang static analyzer. So clang static analyzer can be used when the check requires some sort of control flow analysis. Like I said, clang static analyzer uses both the CFG and AST and does more complex analysis compared to clang-tidy. Whereas clang-tidy can be used as a good choice for linter style checks. So very more uh, code related checks like the C++ code guidelines, where you can do some sort of final replays, and some simple checks, not something related to control flow information or things like that. Checks that are related to certain coding styles, like the C++ code guidelines, or some project specific stuff. Checks that address code readability. So clang-tidy can also run the clang static analyzer checks. So if you look at the list of clang-tidy checks, you can see there are a lot of clang static analyzer checks as well. Yeah, I think clang-tidy is more of a command line tool to run on a single translation unit right now. Yeah, whereas clang static analysis can be used to run on multiple translation units, so it can be allowed to allow you to hook up with the build system and then do much more complex analysis there. So how to use it with your project? So so far we've seen these tools, and how can you use these tools in your actual development workflow. So Jason Turner, who also runs this YouTube channel called C++ Weekly. He's a C++ developer and who also does training and also stuff. And he also gives a lot of conference talks. And he's he's a pro C++ developer. And he has this template project on GitHub where you can just create your own repository based on or fork of the template project here. And it has a lot of all these checks and hookups to these the hooks to these tools available in the project. So for example, there is clang-format that's already there. There's clang-tidy. You can, if you look at the clang-tidy file, it runs all these checks that are available, right? And you can actually build a project that's derived from it. So, and remove or discard away whatever you don't need. And you can have it also comes with a lot more things like fuzzing enabled. So he has developed into a much more full-fledged project where you can have consistent formatting, code static analysis, as well as some lot of security checks. So it's more safer to develop project based on this environment. I think I'll show you that part of it. So this is what I cloned the CMake template project. So the build system used here is CMake, and when I go to the build directory, I'm invoking this interactive version of CMake, and you can also see that it comes with Catch. Catch is a C++ unit testing framework, and so it's automatically brought used in this project so that you can run, you can write and run unit tests without thinking about how to use Catch in your workflow. So that is clang-tidy, and that's already built. You can also run sanitizers. You can also do precompiled headers, and yeah, I'll recommend you to check this repo to see how you can include all these things in your project. If you're developing any C++ project in the future, I will definitely recommend you to fork this and develop based on top of it. So you can from the start itself you can develop much modern, safer C++ code. I think oh, yeah, this brings to the future of C Clang tooling. So though you can build a lot of tools with Clang, there are some design limitations that's described in this blog. I'm not going to go over the details, but there are some future projects that are built that are being built that overcomes these limitations, like the Clang CR project. So like a lot of other projects that are being rewritten to use MLIR, Clang is also being designed to use MLIR as a back um, to generate MLIR. So Clang CAR is LLVM funded project that's built on top of MLIR and is basically an MLIR dialect for C++ based languages in Clang. Its representation level sits between the Clang AST and LLVMIR. So once Clang generates the AST, it then generates Clang CAR and goes through the sequence of lowering and to generate LLVMIR. Um, there's a lot of power in that to do some progressive lowering without directly lowering to LLVMIR, which is much more machine friendly compared to the Clang AST. So Clang AST is a much higher abstraction level. Clang LLVMIR is much lower, but it's not machine, but it's lower compared to the AST. So you lose a lot of information, and what Clang CAR allows you to do is to bridge that gap between bridge that semantic gap. There's actually a functional project called VAST. So they actually there's a LLVM dev talk related to it. So VAST is an experimental compiler pipeline designed for program analysis of C++ programs. It provides a tower of IRs as MLIR dialects. So this is a MLIR project that uses the Clang front end and generates this uh, layers of IR below the Clang AST and allows you to do some sort of program analysis, much more powerful. So I think the folks who developed this project also wrote the blog on the limitations, so you can check that out to see what the limitations are. And yeah, so MLIR allows you to do this sort of complex program analysis in a much more richer fashion. I think that's the end of the talk. There are references to some of the things that I discussed. You can go and check it out. So does Clang Static Analyzer advise on optimization opportunities? Not necessarily, no, but you can build things that since it's based on a CFG, you should be able to build checkers that does that. Uh, on top of my head, I don't see that, but yeah, you can still do some sort of these checks using the Clang Static Analyzer. Yeah. Yeah, you can check out the different performance options that are available in clang-tidy. So what you can do is clang-tidy list checks. So you can just performance. So you can have this performance fastest string find, all these checks that you can run through your code to see if you can optimize your programs. So yeah, I think Ashutosh has already shared a link. So I hope you guys can access the link to the WhatsApp group. So we've created a WhatsApp group where you can communicate, where you can join and ask questions offline. So we can continue the discussion over there. So we started this with the first instance of the talk. So I'll share the link to the WhatsApp group so you can join and ask these questions.
In my experience with Clang, sorry, the Clang linter, all for like I guess there was a difference between Clang 2 or 12.0 and the Clang 14.0 because my documentation changed drastically. So how do I code against that? Hello, am I
Well,
audible?
yeah, I can hear you. Well, I think uh, there's a problem with the other LLVM projects as well because they break a lot of interface. They break a lot of things when they update. So I think there's a problem with a lot of other folks. It's not just Clang. It's also with LLVM. LLVM did a break case change with the opaque pointers, and people have to. Um, I don't know if there is any migration path, but yeah, is there any reason why you want to use the updated version?
No, because whenever as a new developer to any open source contribution, open source repository, I usually expect things to work on the latest version of it. So when I was
Okay.
contributing to, I guess, GCC, then I encountered this problem because in the backend they use clang-format to format their files, and I guess they're still on Clang 9. The format version 9, while the latest one is 14. So I had a lot of trouble battling it with the CI figuring out what was wrong. Then they had uh, I guess, version 9 binary saved somewhere else, so I had to fetch that and then install it on my machine. So that was a bit of a hectic thing to do. So I was just trying to figure out was there an efficient way to do that or debug that process.
Yeah, at least from my experience, it's a problem. Whenever Clang changes, it sort of breaks some of the interfaces. So so the Clang. So when you in the slides on Clang tooling, I've shown a list of tools that are there. So there is libclang. Libclang is you have to use libclang whenever you want a stable interface, and libtooling when you want more functionality. And libtooling uh, changes with every release, and it can change drastically as well. So there's no guarantee on portability across versions. I think that's a problem with general LLVM project itself. They
Yeah,
break
yeah, I
things
understand.
when they update versions. Yeah. I think that's something that we have to live with.
One last doubt I had. Is there any way to visualize the ASP? A Clang tool that provides a visual representation of the ASP rather than just code. Because you were talking about some API calls, so I was trying to figure out was there a project which used those API calls to construct an actual tree, like a more visual representation. Because this is more of a how do I say it? I know this is also a tree, but
Yeah.
something what I'm used to in class or something. Because this tree structure is usually reserved for files when I navigate through files, so that's what I came in mind.
Yeah, I think I don't remember the tool, but I think there should be a way to represent this as a tree. Uh, but the only problem is when this can be simple for small programs, but when things go when there is when the source itself is much larger, it's hard to visualize this tree in a much easier way. So I think this is more user friendly, more scalable compared
Yeah, yeah,
to
fair.
the visual. Yeah, but as
Yeah,
far
yeah,
as I know,
true.
I don't know the tool itself. Yeah, but that should be a way. Yeah, because if you can generate this, yeah, you should be able to generate that as well. You,
Because I remember you can visualize control flow graphs using they are usually outputted as dot files,
yeah.
and then you can visualize them using graphics or something, like Chaitanya points out in the chat.
Okay, I think there should be something to dump this in a dot format. Yeah, yeah, I think that should be a way to do it. Yeah, of course. Yeah, you can write your write a tools that works in
Yeah,
AST
yeah.
and yeah
I was
do it.
just
Yeah,
seeing that. I was just browsing through the documentation to see how the API calls work. So, yeah.
yeah. The interesting thing is that the API itself is well documented, and you should be able to see a lot of projects that use this. And of course, there's the list of Clang tools that actually use the Clang AST. So that itself is much more of updated documentation. So yeah, I think documentation wise things are very good in the LLVM world.
Yeah, yeah.
Yeah,
No,
but you
thank you.
have to
That was
stick to
good.
one
Thank
version. Yeah, yeah. Thank you.
you.